Let's see some more examples of identifying aromaticity. So here's a molecule. It's called furan. Furan is obviously a ring. Whether it's perfectly flat or not, almost all small rings are really close to flat. Being flat is rarely an issue. The real question is, how do we count the electrons, and do we have the right number of electrons? So we clearly have 2 pi bonds. So that's 2 electrons in that pi bond and 2 electrons that are in p orbitals in that pi bond. So we got 4 electrons, but this oxygen has 2 lone pairs, and that would be 4 electrons. And if it's 8, we don't have a proper structure. So as it turns out, we learned something back when we first talked about hybridization. If an atom has lone pairs and is next to atoms that have a pi bond, part of a pi bond, then that atom typically will be sp2 hybridized and will put the lone pair into a p orbital. So as a matter of fact, this oxygen is sp2 hybridized. Let's draw a picture of this. Let's try to draw it edge on so we can see better. So here are our carbons, and their p orbitals are going to form a pi bond, pi bond, pi bond, and here's our oxygen. Now if this oxygen is sp2 hybridized, it has a p orbital and it's going to have an sp2 hybrid coming out. So it has, let's just write this out explicitly. sp2 hybridization, we're going to get 3 sp2 hybrids plus a leftover p orbital. Here is our leftover p orbital, and these remaining sp2 hybrids are going to be in it's a bent oxygen, but these are going to have bond angles of approximately 120. So we're going to have a lone pair, and this angle between those 2 hybrids, it's not a bond angle because it's not 2 bonds, but between the 2 hybrids is about 120 degrees. So we have 2 electrons in this pi bond, 2 electrons in that pi bond, 2 electrons in this p orbital, and we only count the electrons in the p orbital. So we indeed have 6 electrons. Furan has 6 electrons in its pi system. It works as an aromatic molecule. That remaining lone pair on oxygen we do not count, and so we do not have 8 electrons. It is 6 electrons. Let's look at another. This is another structure. It's a ring. Good. Do we have 6 electrons? Well, I don't know. We got a bunch of lone pairs and we have a pi bond, so I guess we potentially draw on 6 electrons there. But we don't need to try to figure this out because this carbon, as a line angle structure, has 2 hydrogens on it. That's going to be an sp3 hybridized carbon. Not every atom in the ring has a p orbital. This is not aromatic. Okay, let's look at one last one. This is a structure called thiazole. Thiazole, okay. So we always count pi bonds. So there's 2 electrons in that pi bond. There are 2 electrons in that pi bond. So then we have 3 lone pairs. That's potentially 6 more electrons. 2 plus 2 plus 6 would be 10. So maybe this is one of our 10 electron systems. It's not. Each atom at most can contribute 2 electrons. So we'll never be able to count both these electrons because we can't put both those lone pairs into one p orbital. It turns out this nitrogen is sp2 hybridized if you go through your rules. This sulfur is also going to be sp2 hybridized. So let's draw this picture. Again, kind of sideways. Whoops. Sometimes I click this button on this pen and it does crazy stuff. So there's our simple carbon-carbon pi bond. Here's our relatively simple carbon-nitrogen pi bond. There's 2 electrons in both those. That gets us 4 electrons. How about this nitrogen lone pair? Why don't we count it? Well, if this nitrogen's sp2 hybridized, we've already used the 1 p orbital on that nitrogen to make a pi bond. We can't also use that lone pair to make a p orbital. So the remaining lone pair will go into an sp2 hybrid. It is not part of the aromaticity count. This sulfur is also sp2 hybridized. It has a p orbital. And the second lone pair cannot also sit in that p orbital. It has to sit in an sp2 hybrid. So here's our structure. We have 6 electrons, and this is thiazole is also an aromatic compound. So these are kind of the basics of identifying aromatic compounds. To do this, what we need to do is we need to be pretty comfortable with assigning hybridization, because only once we assign hybridization can we figure out what to do with our lone pairs and how to count the electrons.